Hello, in this video we're going to go over a problem from 2007 Virginia Tech Regional Math Competition. The problem is asking us to evaluate two sums. The first one is 1 over 1 factorial, 2 over 3 factorial, 3 over 5 factorial. The general terms of this sum is n over 2n minus 1 factorial. And the second one is the sum of n over 2n plus 1 factorial when n starts from 1 to infinity. Looking at these two sums, I realize that the denominators are all factorials. I have seen these types of sums when dealing with Taylor series for e to the power of x, sine of x, and cosine of x. I do notice that these terms are missing the even term. So it's possible that we have to look at e to the power of x and then perhaps somehow distinguish the even terms and odd terms. So let's first look at the power series for e to the power of x. We know that e to the power of x is 1 plus x squared over 2 factorial and so on. In order to get to something that resembles this sum, we need to substitute x by some value. Since I do not have any polynomial in the numerator and you have only things in terms of n, I can only replace x by 1 and -1 and hope that somehow I can get to the n on top in the numerator. So let's plug in x equals 1 and x equals -1. If we do that, we're going to get e to the power of plus or minus 1 is equal to 1 plus or minus 1, 1 over 1 factorial plus 1 over 2 factorial, etc. Now, in order to get rid of the even terms, the 1 over 2n factorial terms, we are going to combine the consecutive terms. So for example, if you look at 1 plus 1 over 1 factorial, that would give me 2. If I look at 1 over 2 factorial and 1 over 3 factorial and I add them up, the common denominator is 3 factorial. The numerator becomes 3 plus 1, which is 4. 1 over 4 factorial plus 1 over 5 factorial becomes 5 plus 1 in the numerator divided by 5 factorial. And finally 1 over 6 factorial plus 1 over 7 factorial becomes 8 over 7 factorial. In general, if I look at 1 over 2n factorial plus 1 over 2n plus 1 factorial and take the common denominator, I would get 2n plus 1 in the numerator, which is 2 times n plus 1 divided by 2n plus 1 factorial. So that means this sum is going to be e. The sum of 2 times n plus 1 over 2n plus 1 factorial is exactly e. If I change n to n minus 1, I would get 2n on top and 2n minus 1 at the bottom. But this time n starts from 1 to infinity since I changed n to n minus 1. Now, looking back at the original sum that we wanted to evaluate, this is almost identical to what we found here, which is 2n over 2n minus 1 factorial, except for the factor of 2 on top. So if we divide by 2, we get the final result of e over 2. Now, let's go back and look at the second sum. The second sum was 1 over 3 factorial plus 2 over 5 factorial, etc. The general term of this sum is n over 2n plus 1 factorial. Let's look at the second sum that we had, e to the power of -1, and let's try to combine the consecutive terms of this sum. The consecutive terms are going to look like 1 over 2n factorial minus 1 over 2n plus 1 factorial. Taking the common denominator, we get 2n plus 1 factorial at the bottom, 2n plus 1 minus 1 on top. That gives us 2n over 2n plus 1 factorial. And it looks like we got really lucky and we got the exact same sum that we were looking for. Therefore, the answer is going to be 1 over 2a. If you like this video, make sure to subscribe to the channel, like the video, comment below this video, let me know what you would like to get videos on, and click on one of the other videos and I will see you in one of the other videos.